This is the last property of Laplace transform. It's called Laplace transform of integral. It's gonna be the last one that I'm going to talk in this class. If you have Laplace transform of ft equal to f of s, then Laplace transform of integration from 0 to t of fu du is equal to 1 over s times fs. Wow, so simple, right? You see that? At first, you have Laplace transform ft, you find is equal to fs. But then you want to find Laplace transform of integration of fu du. That means you want to find the Laplace transform of integration of this function. It's just fs divided by s. Let's see example. If you want to find Laplace transform of integration of x sine 3x dx, first of all, you need to find what? Laplace transform of sine 3t or 3x, doesn't matter. It's 3 divided by s squared plus 9. You see this x, it's just like you have t in the front. Let's recall this. Laplace transform of t power n times ft is minus 1 power n times the nth derivative of s. So you just multiply with 1t, it's going to be negative 1 power 1 and times the first derivative of fs. To do the calculation, you should get 6s divided by s squared plus 9, the whole thing square. Here we go. And now we just want to do the integration of the whole thing here from 0 to t, right? This is going to be exactly this function. So it should be fs divided by s. So we can cancel out the s. The final solution should be 6 divided by, oops, sorry, you don't see that. Okay, so from here, let me say that again. You multiply with t, so using this formula, you get minus 1 times the first derivative, and this is going to be your fs. And by using this definition, if you want to find the integration of function ft, it's 1 over s times fs. So whatever you have here, you divide it with s. So this exactly the same function that we have to get fs. So you do the integration. It's just fs over s cancel out. So this is going to be your solution. Okay, let me summarize all the property for you. This is going to be all the property that we have. Okay. The first one, if you have ft, Laplace transform of ft, it's just fs. And if you have linear combination, c1f1 plus c2f2, when you find Laplace transform, it's equal to c1 and the first Laplace transform of f1, so you get big f1s plus c2 times big f2s, comes from this one. Laplace transform of e to the at ft. The first one should be what? Linearity. The second one is shifting. If you multiply the function ft with e to the at and you do the Laplace transform, it's f of s minus a. And this one, change of the scale, f of at. The Laplace transform is what? 1 over a times f of s over a. T power n ft is equal to minus 1 power n times the nth derivative of fs. And you divide the same function with t, it's equal to integration from s to infinity of fu du. But make sure before you can find fu, you need to find f of s first. Next one, the first derivative of ft has a Laplace transform s fs minus f at 0. The second derivative, after you do Laplace transform, you get s squared times fs minus s f at 0 minus f prime 0. the nth derivative of f, you get this, and the integration of fu du. After you know fs and you want to find Laplace transform of the integration of ft, you can write in terms this form, and it's equal to fs over s. All right. Suppose that we understand all of the property. Let's do example by using the property of Laplace transform. Okay. The first example, Laplace transform of t power n is n fact over s power n plus 1. So if you're shifting this transform with e power at, that means you have n fact wherever be s, you plug in with s minus a, you see? S minus a power n plus 1. Number 2, Laplace transform of sine bt is b over s squared plus b squared. So the Laplace transform of this multiplied with e to the at. Shifting again. It's b, wherever be s, you plug in with s minus a, see? Number 3, Laplace transform of cosine bt is s over s squared plus b squared. If you shift it with a unit, you're going to get s minus a squared, and plus b squared here. Number 4, Laplace transform of t cubed plus 5t minus 2. You see, now it's linearity. It's Laplace transform of t cubed plus 5 Laplace transform of t minus 2 times Laplace transform of 1. So this what? Using the formula, Laplace transform of t power n is n fact over s to the n plus 1. So 3 fact over the first term, you get 3 factorial over s power 4 plus 5, 1 factorial over s squared minus 2, 1 over s. And if you shift this whole thing with e to the 2t, so wherever be s, you need to plug in s minus 2, see? Because we have this function exactly the same function as number 4. So we have s minus 2 right here. Plug in s minus 2 and s minus 2. Is that easy? Okay, see more example. Number 6. Laplace transform of t squared plus 4 times e power 2t minus e to the negative t cosine t. How are we going to do that? First of all, you need to calculate Laplace transform of t squared plus 4, which is what? 2 over s cubed plus 4 over s. And you calculate Laplace transform of cosine t, which is s over s squared plus 1. Here we go. And now this group, you shift it with a equal to 2. So wherever be s, you plug in s minus 2, s minus 2. Okay, we have these two terms. And this one, you shift it with a equal to minus 1. So wherever be s, you need to plug in s minus minus 1, which is s plus 1 and s plus 1. All right. See example 7. Given Laplace transform of e to the at is 1 over s minus a. We know it. So if you multiply t with this, okay, you can do this one first, and then it's equal to what? Minus 1 power 1, which is minus 1. And then you take the first derivative of this term, which is gonna be 1 over s minus a squared. Problem 8. This one is like power 1, okay? It's not the first derivative. So Laplace transform of t times sine bt is equal to minus 1 power 1. And first derivative of b divided by a squared plus b squared. And this is a solution. Please check it out. And number 9, similarly, Laplace transform of what? T times cosine bt is equal to minus 1 power 1 times Laplace transform of cosine bt is what? S over s squared plus b squared. And then you take the first derivative, simplify, you should get this one. You see, I'm note here in question 8 and 9, we use Laplace transform of t power n, ft equal to minus 1 power n, and times n's derivative of the transform fs. Okay, 2 more problem for you. Laplace transform of t squared cosine 4t. Okay, the answer should be 2x cubed minus 96s divided by x squared plus 16 power 3. You can calculate cosine here first, okay? And which you're going to use number 9. And then you have to multiply t squared, so it's going to be negative 1 squared, which is 1. And then you take second derivative of Laplace transform of 4 cosine 4t. Similarly, this one you can think of e to the 2t, which is what? 1 over s minus 2. And then you see here, t cubed. That means you multiply with negative 1 power 3. And then you take the third derivative of the Laplace transform of e to the 2t. And see if you get this solution or not.